Chris.
Yep.
Chris Condron, technical fellow at Event Store, and he helps us designing the database.
Doing that future-y stuff.
The futurist stuff.
And building all sorts of event-sourced applications.
Yeah.
So you had a follow-on question.
Yeah. So last time we talked about systems in general and how event-driven system and distributed system are better served by having each part of it, or the key parts at least, event sourced and in an event sourcing fashion. But we didn't really dig into what is event sourcing in itself. So I guess you have some kind of definition for it.
Well, that's a pet peeve of mine, actually. I have been unhappy with all the sturm and drang around what exactly is event sourcing for a while. So yeah, to answer your question, I think I've got a slide deck I use in a couple of different presentations and talks that I think will help with some visuals to answer this question that is plaguing, I think, the entire industry around what is event sourcing.
Right? Yeah, because there are lots of different definitions, and they all kind of go into the same direction, but they fall short of something every time for me.
And I struggled with that for a while too. And for me, the real problem is they don't define the foundations. They come either out of like an application pattern style, or they talk about it in different ways. And what I realized was it's a storage pattern. It's a database pattern. Event sourcing isn't an application pattern. Event sourcing is a storage choice, right? And that storage choice affects your applications just as much as choosing relational or document or graph would. So it's a really important choice, but fundamentally you've got to come out of the established work in data science to really answer the question, what is event sourcing?
Yep.
So here, let me share these slides that I wrote up, and please interrupt me and let's keep this as a conversation.
Yeah.
And so there's, what's the pattern? Like we've got for messaging patterns, I think everybody should read all three of these books, right? Your application patterns, enterprise integration patterns by Gregor is amazing.
Yeah.
And if you're building distributed systems, you've got to read this. The big blue book in DDD will help you get down to what you really need to be building in your applications. So that's awesome too. So what's the pattern for event sourcing? The answer is we don't have one. We have all these incomplete definitions. Telling me it's not a top-level architecture doesn't tell me what it is. It's a cop-out, right? Application is a left, state is a left fold. That's a functional programmer's, you tell that to a functional program, they're going to get it in a heartbeat. Yeah. But that's not going to tell me what it is as a formal definition, right? Application state is persistent and dependent on the number of things that could apply to is huge, right?
Yeah.
And you see later on that doesn't narrow it down enough. And capture all changes, again, it just doesn't really talk about event sourcing. Because change isn't an event, right? And a lot of this really comes from Martin Fowler, right? His original article that people use as a source, it's not really there's something wrong with his article in the Blicky. It's that it's not a definition. It's a survey of 3 or 4 different types of things and a couple of thoughts he has on event sourcing back when it really first got started. So it's not a definition. It was never meant to be a definition.
Yep.
People using it as a definition caused all kinds of problems.
Yeah.
He talks about mutable event objects. It's like, it's really not where we're looking to go.
Can you go back? Because it's not really a question. It's some thought I just had actually. When you talk about application state as a left fold, and application state is persistent in appending log, and capture all change from application state as a sequence of events. Of the last one, I'm going to change the word events by document. I could do that with a series of documents that I diff. Just like,
or you could do the whole document, right?
or the whole
my
document.
entire state and just drop it in S3 buckets. And I've seen people say, this is how you build event sourcing systems, right? And that's where these fall down. Is like, it's hard to say things that we know are patterns that are going to cause you pain and suffering. Well, that's event sourcing. How is that not event sourcing?
Yeah, right. And I mean, there's value, for instance, of having multiple versions of the same document. We do that in source control, so there is value in that, but that's not
event sourcing, right?
That's not event sourcing. There's some slides being missing for me there, and I'm not sure yet what exactly.
Right. And I think when we're done here, it's going to be really clear what it is and why. And we'll come back to that exact question. So the first thing is that we look at types of storage. We have relational storage. In relational storage, we say we're going to create formal tuples or relations of data, which is the columns, and we're going to organize our data in sets of columns. And that's the tables, and then we add in, on top of that, the ability to create, primary and foreign keys between these relation sets, right? Then there's graph databases, right? And graph databases don't organize the data the same way. They organize as a graph. And if you've ever tried to do an employee table or a nested hierarchy in a relational database, you understand why you want a graph database.
Yep.
I want to look at how things are connected. I want to do tree structures. Relational sucks. Graphs are amazing, right? If I look at document databases, if I'm dealing with a web page and I just want a state bag, especially if one's going to work real with my JavaScript, using like a document DB with Mongo, where I've just got a giant JSON object and it's going to manage that object not as like a local state bag that I've got to worry about, but it's in a real database. Get all those database guarantees. That's going to make my life so much easier. And I'm not tied down as I move through these really short-lived web pages and changes, right? Yep. And then this is the one I think we don't talk about anymore. It's actually older than all the other ones. Ordered storage, right? We just write things on disk in order. We just append to disk. Mm-hmm. That's the fundamental type of storage. And I think ordered storage is a category at that same top level with relational, graph, document, and ordered, right? And it's more than just, this includes all of your logs. Stream databases are in here, like Event Store. It's a stream database. It's a type of ordered storage, right? But all of them are in here. The other big one I probably add to this list is key value stores.
Yeah.
Now, key value stores are very often built on top of ordered storage and logs, but we won't get into that in a moment.
But I think you said the word logs, and for ordered, okay, it's built on top of some kind of log.
Yeah.
The rest is also built on type of log if you want certain properties.
Yeah, so ordered storage is really the sort of proto-log. Ordered storage is using a log. And what you'll find is all these databases use that log underneath as sort of their starting point. But we haven't really called it out as a direct type of storage.
Yep.
What it really is. And we all know it and use it almost implicitly, right? So ordered storage is a persistent mechanism where data is appended in the order it's received into an immutable log. That's it. Super simple.
Okay.
Now let's talk about the patterns we see in this. The first one is a log, like an application log. It's unstructured data. Maybe you use serial log, but I just have blobs of whatever I want. There's no order, rhyme, reason, structure, right? And I don't even have sequence numbers or anything. Ledgers is the next step up. Now we're saying that what's in the log is going to be transactions. And I'm going to write everything down as a series of transactions. And they're probably going to have an order and a start and an end. This is what's behind blockchain.
Yeah.
Right.
And you're talking about, business transactions, not transactions in the database term.
Correct. Yeah, they're not like database transactions. These are like, this is a debit and a credit. This is I sold this. So those transactions that you put into a business ledger.
Yeah.
Right.
Like a bit like you have your car, and from time to time it goes to oh damn, sorry, I forgot the name in English when you go not to repair it, but just to have it checked out on
The
a regular
inspection
basis.
stations.
Inspections. You also have a log of the inspections. Oh, it
Yep,
was inspected
exactly.
at this and this and this was done, and
Yep.
next time is in a year or in 6 months or so many kilometers.
Correct. Something happened, we're going to write it down. Yep. The next one is an event stream, right? And this is things that have happened. They could be stock prices coming out of a market. They could be temperature sensors coming out of IoT. Just generally like physical completed measurements, right? They may be from an application, they may not, we don't know. But I've got a stream of data washing through my system. They could represent application alerts. They could represent, different events. We don't know what they are, but it's a fundamentally different sort of log to have a stream of just events flowing through.
Yeah. But different in what sense? Because one of the things I see in the difference is in the usage. Okay, a log, an application log, that's something for us.
But,
We need that to see, okay, something went wrong in the system. Can we trace back some of the thing? Ledger, I totally understand that in the sense of accounting and stuff like that.
well, so one of the things with event streams is very often they are high volume and they're not persisted.
Okay.
So like you dip a bucket and you see what's going on now. So
Yeah.
if I've got a stream of temperatures or air quality readings in all of China.
Yeah, histogram kind of
Right.
usage.
Well, I'm just going to get a stream of events just flowing on by.
Yeah.
It doesn't have, and so the log can be temporal and like not stored any place I look at it. I might set something up and run it, set alerts off of it, but it's not necessarily permanent storage.
Yeah.
So it can be like a rolling window on the storage, right? And then the next one is, now we're going to talk about application storage patterns, because event sourcing is an application storage pattern, right? It's not a general log. We're narrowing down. And there's 4 things that people very often all lump together as event sourcing. There's command sourcing, change logging, state logging, and event sourcing.
Yep.
Command sourcing is when you save the inputs, you save the requests. Change logging, change data capture. State logging is that whole, I take the whole thing and save it again and again as a new copy every time. And then event sourcing is what we're going to define here. So let's take a little turn, and I found this awesome picture of a Turing machine. Someone built a physical Turing machine. And if you think about using a log, which is append only, as the backing for your applications, we're really talking about using an append only Turing machine. So, and you can logically prove that, and there's papers on it, that you can take everything you could do in a read-write Turing machine, and it can be folded into an append-only, write-only Turing machine. So now we know that our application can be Turing complete, can do anything you want on an append-only log of data.
What's the main? Okay, for the background, I have a background in electronics, not in computer science. So, and probably people who will see that will know about Turing machine, but there's a lack of. What's the main difference? I know a Turing machine is okay. It's going to read forward and go back and rewrite stuff and stuff. And so this one is I only go forward in time.
Correct. So I can write new things on the log, but I can't go back and edit them, because in the classic Turing machine, you can move the tape back and forth and you can edit things.
Mm-hmm.
And we're saying for what we're building, it's just like a Turing machine, but we only write new things.
Okay, but
so
in that you don't edit things that have been done, but can I read them back?
Yes.
Okay, so I'm able to read stuff back. Okay.
So if we look here, like the history of the 5 events that happened go to build our internal state. So I read my history, I get my internal state, I process an input, and I get an output. And then the output goes back into the log, or something from here goes back into the log, right?
Okay.
So that's the whole concept, is that we're building these as state machines, right? That say, given X, Y, and Z, given that an invoice was created and a pair of pants was added, and or a shopping basket. I added pants, I add socks. I remove the pants and I close, that's my history of events, right?
Yep.
And the job of the machine is to evaluate the input and decide on the output. And the output could be 0, 1, or n events, right? Or 0, we could say, oh no, we're not going to accept that input.
Yep.
This credit card is locked. You cannot do a debit like you requested.
Yep.
So, and we'll have actually, in a real application, we'll have hundreds of these possibly, right? All processing. So, in those 4 things we talked about, if you're saving the inputs into the machine, you're command sourcing, right? And in that case, I should really change this diagram, because the history doesn't go to the internal state. The history goes back to the input.
The history goes back to the input. Okay.
Because what you're saying is, I've got these requests happened. I'm going to save the request. I have to go put the requests all back in.
Okay.
Right. So the history, I put all of my requests in again and again and again. That's how I rebuild my state.
And you have to recompute every time.
Well, you're going to have to rerun them every time. But yeah, this pattern is really good in some edge cases. Like if I have an occasionally connected system, I would generally want to command source decisions made in a disconnected system, so I can reapply the commands when I get back to the main system.
Okay. Yes.
Unless that disconnected system has autonomy, and if the disconnected system has the right to make a decision on its own, then we'll do events and we'll send the events back. But if the disconnected system doesn't have autonomy, the classic example here is, police reports, right? If an officer's out in his car editing a police report, the real source of truth on that report is back in the station, right? So I don't want to get too far into that, right?
Yeah.
But his sergeant or his boss might have put something into the report, and what he's writing in the car can't override what the sergeant put in the report.
Okay.
And that's why if you just took the events, then he would automatically overwrite everything when he reattaches. So if the document can be owned in 2 places, command sourcing works better with disconnected. But if the document's only in his car, right, or only on his laptop, then yeah, send the events back and you're done. It's simpler. If we're saving the internal state of the machine, that's either change logging, which is change data capture, or state logging, where you take the entire of the state and you put it down someplace. I've
Okay, I
seen
think
people like snapshot their microservices and put the snapshots in S3.
yeah.
Right.
That's maybe another topic, but we do use snapshotting from time to time,
Right.
but
But
as an
snapshotting
optimization technique, and we do state logging.
as a derived state, that's fine.
Yeah.
But we're talking about the source of state.
The source, yeah. Oh, that's a big difference. Okay.
It's a huge difference. So derived state, you can snapshot all day long. But we're talking about generating the primary source of truth for your application. Right. And that's a giant topic, like source of truth and derived state. Very different. So change data capture, state snapshots, checkpoints on derived state are all awesome things. Very different than this. The last one is event sourcing, and that's where you save the output of the state machine. What was decided or what was produced is what is saved.
Mhm.
And in particular, what we find is that we want to version the events properly with the domain or the business model,
Okay.
not with the state of the service. Now let's talk about that. So this is a big difference here. If I am saving the input or I'm saving the internal state, then I need the exact same machine to reproduce the state of where I was.
Yes.
And that means that I need a version 1 of my service to reproduce the log for inputs or changes from version 1, not a version 2 or 3, right? So as I try and move, so now I've coupled my data to my implementation of my microservice or my
Yep.
state machine, right? If we record the output of the state machine and we align it with the business schema, now I can have multiple versions of it running at the same time. Just because I replaced the service with an updated version, I can still read the events. I can still process them. I still can do other things with them.
So what you're saying there is that the events, the information in the events, and the interpretation of the events are independent of. No. So
Yes. Yeah.
should be independently
Understandable.
interpretable, understandable.
Right. Because they should be parts of the domain or the data model, not parts of the internal of the service that
Yep.
produces them. That's why we talk about events as invoice created, shopping basket added, customer acquired, right? Because these are business things that occurred. Because I want the flexibility to have all sorts of things that process these. It's much more powerful and flexible than, invoice row number change from 2 to 3, right?
Oh, yeah. Or archived.
Archive,
The bit deleted.
right? Row added, right?
Yeah.
Row added value, description, amount, subtotal.
Yeah.
Right? That doesn't tell me anything, right? So this is the difference with event sourcing, right? Is I'm producing events in the business or domain model or data model. Sometimes there isn't a domain model, that's fine. But it's got to be in the data model, which is common to the application and not interior to the service, right? It's
Yeah.
completed changes.
Yeah. Okay.
So logs are unstructured data, ledgers are transactions, event streams are composed of states or facts. Command sourcing saves the inputs Change logging is internal state delta. State logging is the whole internal state. And event sourcing is historical business events.
So has a wide. Why do you say business events there? Because okay,
Because it's not, because I'm trying to capture with that it's in the data model or the domain model, right? It's not just random state. It's stated in terms of the goals of the system, right? The end users of the system, not the particular service I built to create. Like I could have internally, I could model my customer count as as an integer, right? So if I save cust count +1 or cust count equals 5, that's not the same as saving customer added.
Yep.
So I would say that if you're saving cust count equals 5, you're state logging, right?
Yep.
If you save cust count +1, you're saving your change logging. You're not event sourcing. If you save, add customer, you're command sourcing. If I save customer added, I'm event sourcing.
Yeah. Or customer activated or
Right.
stuff like that.
Right. But
I don't really like the word added.
right.
But that's me. The change logging stuff, what you said about because sometimes people also talk about property sourcing.
Property sourcing is this change logging, state logging thing.
Okay,
Right?
so
Because they're saving changes to their properties.
Yeah.
Right? They're saving bits of the internal state of the service that's producing things.
Yeah.
Right. And I want to say there's nothing wrong with it, but there's so much wrong with it. And it's all about the long-term pain you're going to have.
Yeah.
What if you're in a transitional state from like a relational or a legacy system into event sourcing? It can be a bridging technique that could be useful, but what it really means is you haven't defined what your business or data model is.
Yep.
It's really a sign of a weak data model.
Yep. Or there's no behavior attached to the. Oh no, it's not
I don't think
behavior.
you need the behavior, but this is for event sourcing, you just need the facts.
Yep.
It needs to be a completed business or data model occurrence, right?
Yep.
And part of it is, because I understand why you say behavior, because it's not just the change, it's the reason or the description of the change is the event name. So
Yep.
it's the data plus the reason about the data, right? Customer added,
Yeah.
right, with the customer ID,
Yeah.
right, or the customer name. So I have data and a description of why this data matters in my domain or matters in my data model. You don't need domain-driven design. The domain-driven design is really useful in eliciting a really good permanent, low variability business data model.
Yep.
That's the benefit of domain-driven design. By tying yourself to the way your business users talk about something, you get their data models, and the data models that they use will change when they change their mind and
Yep.
will not trip you up. So in no way is domain-driven design required for event sourcing. It's just a really useful way to get a stable model that you can use when you're event sourcing.
I'll add a stable, useful model.
Yes, a stable, useful model.
That's interesting. Then I don't know if you have more slides for this one, or was
Just
it?
on my
Oh,
final.
okay. Can you go back to the one with all the changes there with the boxes and arrows? I like boxes and arrows. Or were you the one with command sourcing and stuff? Okay. What was I about to ask? Yeah, because you said an interesting word, when the business changes mind.
You're right.
And last time we talked about something like, okay, this allows us, or event-driven based architecture,
Well,
composed,
domain-driven design says that your events are going to be stated in the terms of the business. So when the
which is the,
business changes what they're doing, they're going to change their language. And I just generally find they're more acceptable if you say, oh, well, if you want to do that, you're fundamentally changing the business and we got to change the software. Like, oh, yeah, you're right, we are.
yeah,
Whereas if
because
they want to change that doesn't change their model, but breaks all your software, they're like, well, why does that take time?
that's a point. If you go back one slide, I think, if I change my input, this one is bigger. Oh, that's all right. If I change my input, and that happens a lot, my commands.
Right.
Oh, we want to do it differently on the UI. Bong,
I want to do
auto
it,
command.
or I want to batch it. Like, so
Yeah,
I have one command, I save all the commands, and they're like, well, now we want to use batch processing. Right now,
yeah,
it's a completely different command. Right.
yeah,
If we're event sourcing, that doesn't make any difference. I
yeah,
change the service, I change my inputs, they're going to change all the time. I don't care. The output of events that I create don't change.
yeah. And also, when there's some new requirements coming in, internal state will probably change also, because you need
Right.
to take decisions a bit differently, but the
Exactly.
outcome of that decision is always of the same type.
Exactly. So when they say, oh, wait, we need to, this authorization is only good for this amount of time. So now you have to track how long it's authorized.
Yeah,
Right. You do all these different changes. Oh, we need an approval to do this. So now you have to check the approval before you issue it. None of that changes the output because you're just saving the output. It changes your command input, it changes your internal state. But now my log is stable, it's durable, I can still use it. I can do rolling upgrades. One of the things I love about this is I can have multiple services and I can roll in new versions while the old ones are still working
yeah,
because they're all using the same business events.
yeah. And one thing I've noticed in my own experience with that kind of system is that there are changes that happens on the output side, but they're additive. The
Yeah,
I mean,
they
you have like this new
break it.
there's some new information that will come, maybe new events or some new attributes inside those events, but most of the change are additive. Okay, that's if you got it right.
Right. So if you get it wrong, we can talk about that. And there's really good patterns for dealing with, oh, hey, we got this really wrong.
Yeah,
And you can fix it. You just, that's a bit out of scope for this.
yeah,
One of the reasons I like this definition is stating it this way, I can clearly say what is and isn't event sourcing
yeah,
and why. Right? It's like property sourcing is not event sourcing. He uses ordered storage. It does append only. It's not event sourcing. Right? State logging or change data capture, not event sourcing. So if we go back up to here we go. Now we can see why those last two definitions don't really capture because they allow for property sourcing.
yeah.
They allow for command sourcing. They allow for state logging, right? And those are valid things, but those are not event sourcing.
Yeah. That's
And
that makes total sense. And actually, those are desirable properties of of event sourcing. Actually, so
yeah,
they described some side effect. Oh, side effects, side effects of doing it, but it's
right,
not the stuff in itself.
right.
So that's pretty clear. That's a cool definition, actually.
Yeah, and once you set up the whole, you talk about ordered storage and you say why. Once you get this pattern, then you can really describe which one you're talking about.
Yeah, nice. I think I got an answer to my question.
Cool.
Cool.
All right.
I have a lot of other questions, so we'll need to do that again.
Sure, yeah. All right.
All right.
Thank
Thank you. Bye.
Bye.